So, yeah, my name is Andrey. You can find my Twitter handle there. I think I already presented myself in the first room at some point. How many of you guys haven't been there? 3 guys. Okay. Well, I mean, it's quick. I'm a developer with developer mindset, but I'm a DevOps guy as well. So I'm trying to help organizations to actually implement better culture, better automation. You can find my Twitter handle, as I mentioned, but let's dive into that. How many of you guys actually work in the enterprise? All of you. So, yeah, it's always a comparison. Enterprise versus startup, bad versus good. Everybody wants to work in a startup because it's cool. Nobody wants to work in the enterprise because it's kind of boring, but apparently everybody actually is still working there. And the thing is that it's, as one of the many words in English language, enterprise has been abused. Enterprise is just a normal word meaning something that you create as a company. And what we actually think when we hear word enterprise, we actually hear something like enterprisey, meaning that something with a bad shade of approach towards too much complexity, too much process, lack of communication, and all sort of those things. And yeah, please use this word instead if you mean bad enterprise, but don't use the enterprise because it basically means that you also are there. Okay, first let me tell you the story, which happens in the enterprises quite a lot and all over the place. And that it's not a real story, it's a made-up story, but it actually is based on some real facts that I've been facing. So imagine enterprise, traditional organization, which is split up into silos, and well, it's not a big deal. I mean, it's okay in a certain extent that you have development department, QA department, operations department. That's how many organizations are structured. That's not a surprise. Imagine that in this organization you have a guy named Jack. He's a system administrator, and his responsibility is to, manage infrastructure and do operations. So suddenly, his company is deciding that we want to have a new project, very secret project that will change the world, which will make our company flourish and get a lot of profit. So, Jack, we need some servers. We need some servers, and here's the requirements, there's the spec requirements, and because it's traditional organization, it could be that they think that hardware ordering is the most important process in the and should come first because it's always delayed. So they give this requirement to Jack, and he's starting working. He gets some software, some hardware. Maybe he also just starts some service in the cloud. No problem with that, and he starts configuring them. So he starts preparing them. That's what he's doing. Configuring 1 server, 2 servers. A couple of days later, has more servers. 5 days later, more servers. Everything works. But suddenly, well, he almost finished, but suddenly he gets email from another manager saying that, well, Jack, you're already working for that for quite a while. When the service will be ready, we really need to start working on them. We need to throw our devs there so they start producing their best application ever. And Jack says, no problem, I'm almost done. And it's true, he's almost done. The thing is that he's getting another email from his own department, from his own boss, saying, well, Jack, you work in operations department. You know how we work. We have our procedures and templates. You have to fill the documentation for the setup that you did last week. And Jack says, no problem. That's what I do. I know how we have our templates. I can fill in, and I'm almost done. Everything seems fine at this point. He knows how to write documentation. He knows how to configure, how to hand over the stuff to next level. He does that. He did that. He's happy. He's listening to the music. Well, obviously, developers starting to use those environments, and they find that they need something else. And of course, they also probably change the environments in some way or another. And some change requests are coming to Jack's table. It's not a big deal for Jack. Maybe he knows how to do that, but probably the change request was not specified very well. So he configured that, but he basically broke the whole development environment, and developers can't deploy anymore. So they're unhappy. And they start complaining, they're sending mails to management, and everything gets escalated, and stuff doesn't look nice. And, well, of course, because it was the Jack who made the change, he is the one to fix it. And at 3 a.m., he sends a happy mail that, okay, guys, now it's working. You should go and use them. The situation actually doesn't get better because people are starting to abuse and use environments in many different ways. They do change it randomly, and they also delegate some work to Jack, and it's very often is flowing through some ticket management system, and the information usually is lost or not complete and stuff like that. But of course, it's Jack's job. That's what he's doing. He has to keep up with that. But the problem is that what you get in this kind of situations, and I guess some of you or most of you guys have seen something like that, that the situation with the environments, with the things that with the infrastructure is kind of wears that down. They are working. They probably do some stuff, but the problem is that they are in unknown state. You don't know what is the exact final state or configuration setting that is applied to the final server. And well, Jack is not happy, of course, because he has to handle all this mess, and documentation at that point is becoming invalid because nobody wants to support it. Yeah, and that's really not a good situation. Basically, what you get is a chaos in management your environments, and unfortunately, that's what I've seen happening so many times, and it still happens. Do you guys have it? No, you don't. Of course not. Well, you're good enterprises. And when the project moves on, we move to a new phase, to testing, QA, quality assurance. And of course, the situation doesn't get better. We get more change requests, we get more settings, and we get more requests for deployments and stuff like that. And it all comes to Jack. Then finally, to some extent, we are the project manager thinks that the product is fine enough to actually put it to production, and they have set a go-live date, but date-driven development, basically, putting the product in production by the given date. So Jack has to keep up, he has to do that. Of course, documentation at that point is completely forgotten. You have many environments to manage, and all of them managed in a different way. What you do, usually, in traditional organizations, is that you throw more people at that. It may not solve your problems, but usually it could help at least a little bit, but in fact, just making it worse. And because the application at this point is already live, and it's kind of starting to bring some money, so starting to bring some customers, well, management sets the priorities. Everybody is working on production. All these environments are kind of thrown away. Nobody cares about that because they're not the priority. They're not that important anymore. And the operations team is just keeping up to fix the fires in production. What about monitoring? What about monitoring of the production system? Of course, operations guys, they're professional. They know how to monitor systems, and they do that. They have basic monitoring in place. Yes, they do that. The problem is that the monitoring is probably not aligned with what application is doing. So they monitor the amount of CPU being used, the number of the amount of disk space, and some basic I/O metrics. But the obvious problems with the application, like application not serving the requests, is not visible in the dashboard. So managers of the project get the call from the clients earlier than operations actually see that there's a problem. And well, what you can say, well, those people work long hours, very hard to actually maintain the application. And the only thing they can say, I mean, sorry guys, that we do our best. Is there a happy ending to that? Well, obviously, it is. Well, we are in DevOps conference, so we know that DevOps is about solving this kind of problems. But let's see where the problems first. Well, usually when you have these isolated departments or silos that you have to fix the communication first, the communication usually is broken. It's coming through one channel, but never comes back, or comes back in a very fragmented way. So having this feedback loop is kind of important for DevOps to work, but it doesn't work in some situations. And what I've seen actually happening in many big organizations is that, of course, you have to specialize in something, and they have this kind of two different foreign countries inside their own organization. One is the development republic, which more or less most of the developers, they are following agile principles. They do development in agile way. Maybe some of them still do waterfall, but it doesn't matter. But the thing is that operations, they even more divided. They have departments for managing different things. So they could be kingdom of network, kingdom of servers, kingdom of monitoring, and those guys may not even talk to each other that often because there's two different components. They try to specialize and isolate themselves. And basically communication between devs and ops becomes like, communication through Ministry of Foreign Affairs rather than, people talking directly to each other. And the problem is usually that operations guys, when they have a task to have the system stable. So they want stability. Developers, they want agility. They want to produce more changes. So these things seem like, opposite. They move in the opposite direction. So that they may seem like they're conflicting. But actually, the goal is for like DevOps organization, DevOps team, is to provide stable agility or agile stability, something like that. But what I've seen in enterprises is that the so-called stability that operations guys try to promote is actually coming to a stagnation. So they want to have stability, but without any moving parts. But it should be the other way around. Another thing that affects operations department a lot, and that's a guy called Jin Kim who wrote a blog post about that, is that unplanned work can kill your organizations. Of course, operations department, they have to manage failures, they have to manage backups, they have to manage scheduled system maintenance. They have to do that. So they have another work apart from supporting developer needs. Sorry. And if the development produces the changes more or less the same rate, the same change rate is coming with the same development team size, but the more the product is progressing, the more failing. If you don't have control about how many of those changes actually failed, then this basically gives more work both to developers and to operations, and this increases the amount of unplanned work on the team level or an organization level. And obviously, if from a management point of view you don't control this unplanned work, then at some point unplanned work may become more bigger than the time that you have. And of course, it means overtime, it means unhappy people, and eventually this can kill teams, organizations, projects, and people may leave, and this is not a happy situation for anyone. So controlling how things are being applied and why they're failing and why they're applied in a not a great process is quite important to follow up. Another thing that influences unplanned work is the number of unique configurations we have to manage. So imagine, like in the situation we had in Jack's organization, when we have several environments with completely unique setups, then of course, in order to manage each of those configurations, you have to be skilled enough and know enough about what was the reason and why each one of them has different configuration. On the other hand, if you have to support, like, let's say, various operating systems or various middleware versions or various programming ecosystems, you have to, in order to be efficient in them, you have to kind of provide some kind of level of mastery. But if you have many of them, you can't really focus on all of them. You have to, you will actually have the mastery level for each one of them will drop because you have limited resources. Because of that, because of limited mastery of each configuration, the change success rate will actually also drop. And this will eventually also increase the amount of unplanned work. So, yeah, obviously, DevOps is something that is trying to solve this, and something that should, I think DevOps is really something that should be taken by any enterprise, and at least the practices, the main principles, and they should try to avoid the problems that we saw before. It's not that important for startups to implement DevOps practices because they will do anyway. It's more important for enterprises to actually try to understand why they're so slow sometimes, why they have these operational problems, why they have so long time to market. And DevOps should kind of allow this to solve. So of course, fixing communication first. So instead of removing the boundaries maybe, and try to make those people play on the same field and have the feedback loop coming back and forth. And the most important here is not for these people. Actually, you see, it looks like a football game field. So you are the spectators, the clients of this company. It's more important for them to see that these guys are working in concert rather than they are delaying everything. They provide bad service. And if they actually do work in concert, then the game that they provide, the show, will be very well observed by spectators, by clients. Of course, sharing responsibility is quite important here. So we have to share responsibility for the system, for the business, for the project, as a common thing between different departments, different skill sets. And in this case, it's kind of obvious that number of failed things that have been applied in the wrong way and deployed in the wrong way will go down. Unplanned work will go down. And also, if you try to, in operational concerns, if you try to minimize the number of unique configurations that you have in your project, in your organization, this obviously will allow you to increase the mastery for each configuration, and this will obviously also allow you to increase the unplanned work. Of course, you should not reduce it to a number of 1. So it should be reduced to a minimal level that makes sense. Okay, great. So DevOps is great. Now everybody's heard about DevOps. All enterprises, all businesses know that DevOps is kind of cool. Let's do it. It will definitely save the organization and change the way it works. Well, maybe. But the thing is that DevOps, I think, at the moment, it's quite highly misunderstood. Many managers have heard about it. And of course, now recruiters also heard about it. And they start and go and search for DevOps engineers. Well, I don't think that DevOps engineers is something that exists, because DevOps, to me at least, it's an adjective. It's a mindset of a developer or for engineer. So when you search for developers, for example, you don't really search for agile developers. You don't care if he has Java or not. You care about if he has Java skills, Ruby skills, PHP skills, whatever. And you kind of expect that he has agile mindset. The same goes for DevOps engineers. You don't really need DevOps engineer. You need people with DevOps mindset so they can build DevOps teams. But from a skill set point of view, you need Linux administrators, Unix administrators, Windows administrators, someone who knows how to operate clouds and stuff like that. But you don't need a DevOps engineer, because that's something that's very broad and very undefined. And there's natural rejection coming from developers and operation guys, because we have a misunderstanding of what it is. Also, when enterprises and businesses try to apply DevOps practices inside their teams and projects, they come up usually with some topology of how DevOps actually should work. And there's a guy called Matthew Skelton who came up with generalization of different DevOps team topologies, types and antitypes. And I will start with antitypes first. So the first one is basically you have devs and ops. That's the usual antitype for that DevOps is trying to solve. Two teams isolated, throwing deliverables over the wall. They have a wall, they don't have communication. That's definitely antitype. Another one that happens as a first reaction to introduce DevOps in the organization is to create an isolated DevOps team, target team. So I guess most of you guys have been at Warstock today, and this is the target team. It's trying to implement the practices, the tooling inside their own silo. So basically, they're violating the main principle of DevOps. They're trying to create another silo instead of bringing back, breaking the border. Because the target team can just, work a lot in isolation, but the end result will never be accepted by anyone, because at that time they do some real work. Another one that I actually mentioned already in my previous talk is like kind of DevOps. So when developers think that they don't really need ops, and they have APIs, they have cloud providers, they have a lot of tooling around, so they say, we don't need you guys, we just do everything ourselves. And the problem is that it may end up quite tragically. Actually, there was an organization that developers tried to manage infrastructure for themselves, but at some point they lost all production data, all their client data. So guys in operations have a lot of experience in security and backups and maintaining the systems and migrations, so definitely important to use that experience. Another antitype that actually also is kind of similar to antitype B, it's just when there is a separate team inside development department which is just focusing on DevOps tools, that's how to say, but still the wall is still there. So they do something for their own pipelines, or own deployments, and all infrastructure management. But operations, they don't accept it, or they just don't know that these kind of things exist, and still the deliverables are thrown away or thrown over the wall in the same way. So tooling team doesn't solve really the problem of the communication. Another antitype, and that actually quite common misconception of what DevOps is that DevOps is a new name for system administrator. Well, it's not. And it's kind of opposite to the type, an antitype D, when the tooling team actually is here, and they try to implement the tools to their vision. So operations try to implement the tooling, the deployment pipelines, everything to their vision, but they don't really get feedback or input from developers. So of course, again, the wall is still there. It doesn't disappear. Now the good types. Of course, the good types are the ones that we actually collaborate. We have collaboration, we have good understanding of each one's requirements, and probably cross-functional teams are created within the organization, and we have this feedback loop working. The type 2 is kind of very similar to type 1, but this is actually can be applied to organizations which are like single product organizations, like Facebook or Netflix, where they have teams where you actually can't really draw the border between are you dev or ops, because you actually most of the people actually do everything. They are responsible for the whole product pipeline, and they implement infrastructure code and application code at the same time. So the synergy is a much higher level, and this type 2 is definitely not for everyone. But type 1 is kind of, I think, something that should be implemented on every level. Another type is type 3. It's kind of similar to some of the antitypes, but in this case, we have infrastructure as a service or platform as a service handled by an organization, external organization. This type 3 can actually be good for small companies, but the only important requirement here is that this team completely understands the capabilities and service level of these guys. And they know that it's completely what they need to deploy their applications. If they do, then this kind of setup can work pretty well for implementing DevOps, because you're just outsourcing part of the ops part, and you know exactly what to expect. It's not just, I'm using API, that means that I'm already doing DevOps. No, it means that you have a complete understanding of how it works and what it provides. Another possible setup, again, for smaller organizations that could be, is that you have external service provider which is focusing on providing services around operations, and they have experience, obviously. So if this is a small organization which doesn't have a lot of skill set and money and budget to actually onboard more people in their team, they can share that responsibility with the external company. But the important requirement is that there is actually a cross-organizational team that works together to meet the requirements, and they communicate very well to deploy stuff and other stuff. Type 5 is it's actually almost the same as antitype 2, antitype B, but the only difference here is that the DevOps team is actually having an expiry date. So it's actually fine to create a temporary team that's only goal will be to self-eliminate when they reach their goal. And their goal should be to bring devs and ops together. So basically, when these bubbles are moving together, this team will be smaller, and suddenly disappear, just fade out, and go to the other teams. So if you create a DevOps team with the purpose of facilitating the DevOps principles, then it's a good type. If you just create a DevOps team to focus on tooling in isolation, that's a bad thing. Okay. Is it okay? Clear? Everything?
The last slide. That sounds like a project. So what happens if the project manager in charge of the temporary DevOps team? Is it a pattern or an anti-pattern?
Well, if project manager if project manager is the last resort to like resolve any issues, then probably not. But if project manager is just kind of an accountant to see the workflows and maybe set some priorities, then it's fine. I mean, why not? I would say that it should be more named like a team lead. So he's leading the team, he's knowing the main goals of the team, and he's trying to manage just the workflow.
So the basic principle for this is like a self-organizing team?
More or less, yeah, more or less. Because their main goal should be like, go here, try to find good people, bring them together, maybe raise discussions on the tools, let them delegate some of the work to them, to this team, to that team, to actually to facilitate. Their goal is to facilitate. And probably they will also implement some tooling themselves, but again, their goal is to not just implement it silently, but actually explain why they do that, what is the reason, get the input from everybody, and then they can kind of bring benefits to the organization. Otherwise, if you do it isolation, then yeah, it's usually a throwaway product. Yes?
What happens when this team disappears? Let's say
Nothing. Well, I mean, well, basically, when this team disappears, it goes to type 1. So basically, the two bubbles smash the team, and the team members will just fade out and go to other teams. So they should be like, improve the gravitation between the two. Okay, just few technical tips that I can give to businesses that want to start looking at this direction, and I think you can actually start on a quite small scale with small things. You don't need to, hire DevOps engineers or DevOps facilitators and help you out to move things. You can actually start with very small things, and just to get it. The first thing you should do, of course, you have to talk more. Devs and ops should just talk more and get the understanding of what are the drivers behind each other, and what are the requirements, what are the important things that has to be handled, and why the one group is angry at the other group, and what are the reasons. So talk more, share. Well, everything should be shared, because that's the only way you can facilitate some of the knowledge exchange. So some hints to the developers, especially those who don't talk that much to operations. Well, don't ignore operations. It's important. It's important to build in the operational mindset into application quite early enough, because if you don't, then yeah, you will get calls, you will get angry customers, and all that stuff. The first thing that most of the developers kind of forget, and then everybody does that, everybody is guilty. They're writing too much logs, or they're writing the log messages that are debug messages that have no relationship to the business logic and have no value at all to the business. The thing is that log statements actually sometimes they are being read by the guys on the other side, by the ops people. So they need to have a good understanding of why this log is thrown and why the application is failing. And if you are producing too much noise as a developer, or you don't care about the logging at all, then this can actually disturb much more. Actually, it can hurt. This is one of the simple aspects of application being operationable, and that's some developers actually forgetting. So logs should be, I think, they should be parsable, but at the same time, they should contain information that is more or less human readable, because in this case, probably not. It's a lot of numbers. Another thing, another interface towards operations that any application has is configuration. And unfortunately, in business environments, I have seen business applications that have a lot of, blows and whistles, how to configure that, and those are completely not up to standard, don't have good naming, and they're not backward compatible. There's no good defaults for them, and basically configuration is an interface, another interface, but to the operations guys, and it should be good enough for them to understand it without reading any documentation. So yeah, obviously Windows registry is not the best way to define your configuration settings, because it's a lot of mixes. For example, what's that? Don't load? Why? Another important aspect, another interface towards operations is actually monitoring. So we are already talking about three different interfaces that operations people usually face when they manage your application in production: logging, configuration, and monitoring. So applications should be monitorable. You should embed the monitoring capabilities into the application and make them use known protocols and expose good metrics that operations guys can consume using their tools. Like, and if it's Java applications, it could be JMX. Usually also most applications support SNMP. And it's important for developers to actually know what those protocols are and use them to make application monitorable and manageable. Yes. Of course, you have to create dashboards. Dashboard is actually should be part of the application, should be developed together with the application, because this would help application to be maintainable and will bring important information. And most likely you will actually show the most important information on dashboard when you develop that, because you don't want to show everything, because it's probably will be overwhelming. But if you develop your dashboards together with the application, you will quite soon come up to the fact that you will only expose the useful metrics. Also, try to align early with the operations. I've shown this slide on my previous presentation, but I think it's quite important. If you're still in waterfall, which sometimes happens, then if alignment happens here, then obviously number of issues is going down. But if it's an agile process, you can have many waves, but eventually the final alignment still happens in the end, which doesn't make sense. You have to align as often as possible and as early as possible. Also, I would say that developers should learn, or at least know, how the provisioning tools operate, because this is another interface towards operations, that most of the operations actually may use these tools, or at least try to use these tools, because they provide an additional language to express your architecture, actually. You can define the components, you can define the dependencies between components, and these tools allow you to do that. Okay, yeah, I'm actually not running out of time. So another thing that developers can do, they can try to build a clone of development environment or actual production environment with the same operating system, with the same components, same configuration. And the thing is, it's possible with all the virtualization options that we have at the moment. You can run virtual environments on your local machines, because our machines are quite powerful at the moment. Also, you can use the cloud. And that's not an issue. That's really not an issue. You should not, again, say it works in my machine. You just reproduce the environment. Start a virtual machine. Use the same scripts to provision that machine. Use the same script to deploy code to that machine, and then you have the same exact machine, the same exact configuration that runs in production. So it's not an issue. In business environments, it still is. People don't like that. They sit in their small boxes and silos to want to work in the way they kind of work, but they don't want to come to realization that it's actually possible to have almost exact clone of what you have in production. Another interface towards operations for developers could be the package managers. Again, it's often the case that application with many components is delivered to operations in the form of disassembled parts that operations have to assemble again. So why not to use already good formats to actually bring them together? So there are many available for various operating systems. You can just package your application as RPM, as a Debian package, as a container, and give it to operations so they can consume it. And publish that to artifact repository, kind of isolating the building process, testing processes, and the deployment processes. And again, I already mentioned that in previous presentation, but I think it's quite important. Automation over documentation. It's much more powerful tool than trying to force everybody to support documentation, because everybody hates writing documentation. I know that. I don't know people who just like it. It's impossible, especially for the moving parts. If you have to update the documentation every time you have a change, that's annoying. Forget it. Just use the code. Code is the best thing. Of course, developers should try to automate everything. That's no doubt about that. Some hints for operations as well. Well, first of all, get those dev developers to solve production problems. It works. It actually works. It will actually help developers understand what are the problems that their code produce, and yeah, that works. Also, make post-mortem analysis to have an ability to understand what actually failed and why it failed, and try to fix that in the next iteration. Monitoring, again, it's important to have monitoring, because developers should expose the proper interface. Operations guys should consume that, and they should have an alignment there. They should understand what are the KPIs, what are the important things. Also, logging. Unfortunately, that's what I've seen in many enterprises. Again, logs are just lying on the servers, and nobody cares about them. And when you need to find a problem, you go to one server, second server, third server, fifth server, and yeah, that's a painful process. So there are tools, obviously, to aggregate stuff and to analyze logs and to rotate them, clean them, and stuff like that. Again, this is another interface that everybody should either expose or consume. Provisioning tools help to define the architecture, the components of the software. And since it's code, infrastructure is code, I already told that in previous presentation, well, maybe get some help from developers to actually help you out with the code. And keep it in version control. Operations guys should learn how to use version control. Again, in many enterprise environments, it's not the case. They still use cumbersome UIs, GUI wizards to do the maintenance and management. Try to express the code and keep it in version control. No other options. Also, give feedback back to dev. So if you change something in production, this should be expressed in code and be given back and tested again in the test and QA environments. Of course, prepare for disaster, because that's what, well, actually, that was mentioned many times, like mean time to recovery. If you are ready to recover, you have backups, if you have rollback procedures, then it's going to be much less painful for you, and you're going to get a much better result. Okay, I think nobody actually in this conference yet mentioned any kind of books to read. At least I haven't seen. So the one that I like a lot is Phoenix Project. It's written by Jim Kima, whom I already mentioned. It's about IT manager in big corporations. So it's really very much about DevOps in the enterprise. Continuous delivery, obviously, is important. Another one is Release It. It's very similar to continuous delivery in what kind of message you want to give. And I think it was released at the same, or issued at the same time as continuous delivery, but this just looks at the problem from a bit different aspect. Another one interesting is this inviting disaster. It's not really about IT, but you can see quite interesting patterns in there. Some blocks, and that's it, I guess. Any questions, or do we have time for questions?
2 minutes.
2 minutes. No questions. Everything is clear. Everybody start, I guess.
There's beer waiting outside.
Exactly. So thank you then.